Hey guys, welcome to the next video on OpenCV tutorials for beginners using Python. In this video, we will talk about Canny edge detector in OpenCV. So first of all, what is Canny edge detector? So the Canny edge detector is an edge detection operator that uses multi-stage algorithm to detect a wide range of edges in images. Now this Canny edge detector was written and developed by John F. Canny in 1986. That's why it's named after his name, which is Canny edge detector. Now the process of Canny edge detection algorithm can be broken down in 5 different steps. The first step is to apply Gaussian filter to smooth the image in order to remove the noise. The second step is to find the intensity gradients of the image. The third step is to apply the non-maximum suppression to get rid of spurious response to edge detection. The fourth step is to apply double threshold to determine the potential edges, and the fifth step is to track edges by hysteresis. That is to finalize the detection of the edges by suppressing all the other edges that are weak or not connected to strong edges. So this seems little bit complicated, but in OpenCV it's really simple to use. So there is a built-in function in OpenCV which is called Canny, and we are going to use this function. So to start with, I have this sample code which loads this image which is called messy.jpg using the matplotlib library. I'm going to just run this to show you the result. So this is the image, and we want to detect the edges of this image. So what we are going to do is we are going to first of all declare a variable called Canny, and then there is a method, as I already said, inside your CV2 library which is called Canny method, which takes few arguments. So the first argument here is the image source itself. The second argument and the third argument, as you can see, is the first threshold value and the second threshold value. So this first threshold value and the second threshold value you need to provide for the hysteresis procedure. So there is the last step, as I mentioned, and in that step hysteresis take place, and for that procedure we need to provide the values of the threshold 1 and the threshold 2. So for now I'm going to provide 100 as the threshold 1 and 200 as the threshold 2. But later you might want to add a track bar in order to see the changes in the edges when you just move the track bar from left to right for the threshold 1 and the threshold 2. So this might be a small assignment for you. You can just add the track bar and see how the edge detection changes when you change the value of threshold 1 and threshold 2. And I have already explained how you can use track bars with OpenCV. So just watch that video and you will be good to go. So now we have the result of Canny edge detection function. So we are going to just add it to our list, first to the list of titles and then second to the list of images, and the range we are going to increase it to 2, and this we are going to just see the images in 1:2 format. So I'm going to just run this Python script and see the result. So you can see we have the original image here which we have loaded in the grayscale, and on the right hand side you can see the result of the Canny edge detection methods. So you can see all the edges which are available here on this messy5.jpg image. You can use this on the other images also. So for example, I have the lena.jpg image. Let's see the result of that, and this is the result of the Canny edge detection method on this lena.jpg method. So this Canny edge detection is really useful because in the last video we have seen how to find out the image gradients, and let's see in comparison to those image gradient methods how Canny edge detection method performs. So these are all the methods I have explained in the last video: Laplacian, Sobel X and Sobel Y, and I have shown you how to combine the result of Sobel X and Sobel Y. And additionally I have added this line to the previous code which I have shown you in the last video, which is edges is equal to cv2.canny, which gives us the result on the same image using the Canny edge detection method, and I have added it to the title and the image, right? So let's run this script once again and let's see the differences in the result using all these methods. So you can see all the 6 results. This is the original image, this is the result of the Laplacian method, this is the result of Sobel X, and this is the result of Sobel Y, and this is the combination of Sobel X and Y. And you can see Canny edge detection gives us the result which contains lesser noises. So you can see there is a lot of noise present in the other methods. You can see here all the noise is present which is removed using Canny edge detection, or in the Laplacian method also you can see some noises around, but in the Canny edge detection method you can see you get the proper edges and more precise edges without any noise. So this is the benefit of using Canny edge detection. So this is how you can use Canny edge detection in OpenCV. I hope you enjoyed this video and I will see you in the next video.